Yeah, hello. Hi, everyone. Welcome. This is the last talk of the tech track. I hope you are not too tired. I'll try to make this as interesting as possible. So today we're going to talk about abusing the rules, finding business logic attacks, but I kind of focused on our latest research, which is about vibe-coded applications. So welcome. Oh, shit. Oh, well, why did it? Okay, the clicker is not on my side. So my name is Noé. I'm a research and development engineer at Escape. I lead the ASM project, and basically my job is to automate discovery and pen testing. I'm kind of an at-scale nerd, so I love to take stuff and running at a large scale, like internet scale. And I do open source too. Oh, wow, the clicker is really buggy. Sorry for that. Okay, so what's Escape? Escape is an automated pen testing platform. And we do everything from discovery to security testing, and we try to automate this process. Okay, so at Escape, we have a habit of doing research on exposed applications. We've published several reports. Today, we are going to focus on the state of security of vibe-coded applications. You can read the full report here. I will, of course, not have time to present everything in the report, so this will be like a synthetic view of that. But there it is. The clicker is really buggy. So first, little introduction. What is vibe coding and how did we get to from LLMs to vibe coding? So as you all know, there has been a big rise in adoption of LLMs to generate code around 2023 with just plain ChatGPT or tools in your browser where you will outside of your IDE, you will just prompt the LLM and then copy paste the code and run it wherever you want. Then we started to see some tools appearing inside of the IDEs, the first one being GitHub Copilot, and then some more advanced tools like Cursor or Cloud Code, which run directly close to your code. And this created a trend which is called vibe coding, which is you just prompt the agent, you never touch the code, and you let the AI do everything on its own. And now we see a shift to full AI platforms like Lovable or Base44, which brings it back out of the IDE. And the idea is that you just have a chat interface, but the platform will deploy the code for you, will deploy the front end, the back end, set up everything, the infrastructure you need, and basically just generate your application. So, little question to the audience. How many of you do use LLMs or AI in your day-to-day job? Yeah, basically almost everyone. And is it to code? Who does use it to code? Yeah, a lot of people too. So you probably have the same gut feeling as I do. The LLMs, they create weird results, bugs, hallucinations, and they do even when you supervise them. So probably fully AI-generated code might be worse. Also, those platforms, they lead to unreviewed code. It's completely obscure. You never see the code you're running. And it's also created by less technical people. The full appeal of those platforms is to bring everyone to develop code. Probably some of you have experienced your CTO vibe coding something like, hey, I have the next $1 billion app. Let's just ship it to prod. And it's connected to your database, and you're basically screwed. And those platforms, what changed is that they can now generate the front end. This is kind of old, but now they also generate your backend and your database. And this database and this infrastructure that it generates can handle sensitive data, etc. So might be a problem that the AI is the only one in control. So we wondered there might be some security issues there, and we wanted to test that. Oh, wow. Yeah. On top of that, there is a first catalyst, which is there is a clear increase in API services count and complexity in companies in general. Our previous research identified that there is, on average, about 15,000 API endpoints per organization, which is that many entry points to your code and that many entry points for potential vulnerabilities. Also, we found some extreme cases of organization having 3,000 API services for a single organization multiplied by dozens of endpoints. Very large attack surface. The second one, oh shit. Okay, sorry. The second one is there is also an increase in attacks on those APIs. This is a report by Kong, and they basically forecasted that by the end of the decade, there will be a 1,000% increase in API attacks. So if we combine all of that, so our gut feeling and those catalysts, we kind of get an explosive cocktail. The companies, they have more APIs and endpoints that they can track. Those APIs, they are more diverse and complex than ever. And there is an increase in attacks. And boom, vibe coding on top of that, there is no more human in the loop. What could go wrong? And so that's what we wanted to test. So we started trying to pen test those vibe-coded applications. So first we have to discover them. How do we build the data sets of such applications? We needed a source. Our first source was Lovable Lunch. It's like kind of dashboard, like rankings of vibe-coded applications where you can submit stuff that you made on the platform. So very easy to scrape, good source of lots of applications. We combined that to other sources. We identified some fingerprints in the JS code that those frameworks, like applications, will inject in your JS code. So we are able to take that. We also enumerated the subdomains on which they deploy the applications and other techniques. And so in the end, after filtering a bit, we get 5,000 base targets to pentest. We fed those 5,000 targets into the Escape attack surface management to perform even more discovery and security testing at scale. Basically, this platform works as the following. We take assets, which can be like of very various types. What interests us today are mostly host API services and web applications. We run that through scanners, which can be of various types too. So either ASM to do discovery or some DAST or business logic security testing to find vulnerabilities. And those scanners will output assets, so discovery, and this creates a feedback loop. And we can put those assets back into the scanners, et cetera, expanding the attack surface. And it will report some vulnerabilities. Let's take a look into one of those scanners, which is the main one that we used in this research. It's our web application DAST, because those were mostly web applications. So basically how it works is that you take the application, you start a browser, you go to the application, you crawl it with like some AI or different techniques to get into all the possible paths. And then we perform some injections and security checks to find issues. While we are doing that, we hook into the browser, so we are able to get all the JS sources of the application, and we also hook to every network call. And from that, we are able to run some passive checks to detect eventual secrets of personal information. And we also are able to extract the APIs that those front ends use and to reconstruct the schemas from the runtime requests. And we also associate that to the authentication, like we can extract the cookies or the JWT session or whatever. So after running that, we quickly discovered that Lovable uses Supabase as default to generate their backends. For those who are not aware, Supabase is basically just a Postgres as a service. And what they do is basically they generate your front end, and then they call Supabase via their LLMs and agents to configure your database and your API that is built on top of the database. And they configure everything for you, like the schema, the row-level security, which is what you use in Supabase to control which tables or objects are accessible or exposed in the REST API. And this raised some concerns to us, because generating your schema from an agent is probably a bad idea. Generating the access control is probably a bad idea too. And having used Supabase myself from some small projects, the RLS is easy to mess. Even if you are experienced and you know what you do, it's easy to just miss something and expose a table that you don't want to expose. And there has been a reported CVE on that, which was that Lovable was basically setting up the database with like everything is accessible first, and then trying to control, blacklist some of the tables, which is like not what you should do. You should do the opposite, of course. So we'll try to see if we can identify this CVE. Did they fix it? They told that they kind of fixed it, but you'll see. So from this discovery, we started with about 5,000 targets. We discovered 15,000 assets in total, and out of which we extracted about 1.5 web apps that we want to pen test, and about 500 super-based APIs. I'll just explain why we filter those and how did we do that. Basically, for the front ends, a lot of those were just like either landing page or broken or authenticated. Authenticated, sometimes it was even just like join a waiting list or something like we could not register. And so a lot of broken apps too, like vibe-coded applications were really broken, just like websites. You go to the website, it's just like 500, or you click on a button, it doesn't work, it just crashes the website. Lots of broken applications. Same for the APIs. We focused on the super-based APIs, so we removed the rest, and we had a lot of dead APIs or broken APIs. So we focused on the green parts there. Then, okay, now that we have those targets, how do we assess the business logic security testing of those backends and those APIs? Let me explain a bit how we do that at Escape. So this is the full scheme. We start with the lovable. For a quick recap, we run it through the ASM scanner, the scanner that I presented, and some other scanners to find some metadata, stuff that could interest us. And from that, we extract the Supabase API and the JWT that is needed to connect to it, that is usually hard-coded in the JS files. And we construct the schema for it, and then we're able to fit it in our security testing scanner. How do we do this testing? Basically, our scanner, it takes an expose service and a schema. Then we run our technology to find business logic flows and leaking data or secrets. Let me explain how this works and why it's hard to actually assess the business logic of applications. When you try to automate pen testing of APIs, you face two main problems. The main one is that if you just randomly fuzz or you just try to brute force the API, you will not ever be able to get past the validation layer, or very unlikely. You will just send requests, and it will get rejected if the application is correct, because you do not know what to send to the API. And that caused most of your requests to be blocks, and so you end up not testing the application itself or the business logic, you just test the network layer and the validation layer, which is not interesting and which is where a lot of dust tool fails. Our solution for that, it's a bit of a buzzword, but sorry. We use AI-driven semantic API exploration. Basically, that means that we are able to quickly learn from the API, and we are able to craft payload that will get through the validation layer to identify which of those payloads work, and then reuse them to build exploits. I will come back to that later. The second problem is that even if you are able to get past this validation layer, it's basically impossible to explore every possible combination in the API. Like, this is a classic problem when you try to break something. So what we do for that is we use reinforcement learning to build basically a tree of possible outcomes we are searching for in the API, and we prune the branches that we are not interested in. Let's take a quick example on how we do that. It's very simplified, but so you get the idea. Let's take a GraphQL mutation. I took GraphQL because it's just easier to represent than REST, but basically it's the same. We have, imagine like a hotel room booking system. We have a mutation that is book room. You should pass it like a hotel ID, which is an integer, room type, which is a string, and a guest email, which is a string too. The naive approach, very naive approach, would be to just generate random stuff and send it to the API. Of course, this will like never ever get to any code path if your API is not completely stupid. We send like 1, 2, 3 for the hotel ID, random string, random string. This only respects the schema, like the primitive types, but not the intended logic that you should send to the API. So what we do here is we combine what I mentioned before, and we basically use previous responses. Like, imagine we have a query list hotels. We are able to extract stuff from that, like, for instance, the room type, which is like an enum, and we will reinject it. The ID too, we will list it, reinject it, and the email, which we might have created from some register routes or login or whatever. And then, with this request, we are able to actually craft a valid payload and get deep into the code path. Once we are able to do this, we basically just explore the API, map all the possibilities, prune the stuff that is not interesting, and then build chain of attacks. So basically here, very simple chain. We register, then we take the email. We could take the hotel ID room type from what I presented before, inject the guest email, and then boom, we modify the request that was legitimate and successful, and just try to inject stuff in this legitimate request, which is much more likely to get deep into the API and actually find stuff. So the benefits of using that is that with a naive approach to Dast, you just basically test the network layer or the headers or whatever, and you will have issues like, hey, some control security header is missing, which is not very valuable still. Why not? But it's not what you want to test when you have pen testers. With this approach, you are able to test very complex business logic flows, such as like tenant isolation. You create 2 accounts. You check, OK, yes, I'm able to create this resource. Can I access it from the account B? Can I modify it from the account B if it was created from the account A, et cetera, et cetera. So if you want to learn more, we have an article on that too. It's very hard to explain it all in just a few words, but this was a very simplified version of it. Of course, it's much more complex, and you can read that if you're interested. So the interesting part. What did we find? Enough words. Let's go to the results of the findings. Just a little disclaimer. As I mentioned, a lot of those applications were broken or untestable. Yeah, vibe-coded applications are really broken. You can trust me on that. A lot of those were behind authentication. We are trying to automate authentication right now. We ran it a bit, but just on a tiny portion of it. It's really hard to scale. And also, we ran all of our scanners in a surface or production mode, which means we made them as harmless as possible, not to break stuff on the internet for people that did not ask us to. So we disabled a lot of checks, like very hard injections, etc., and we disabled state-altering operations like post, or like delete user, or stuff like that. But we still found quite a lot of stuff, quite a lot of nasty stuff. Around 35,000 vulnerabilities, of which we identified 100 as critical and manually reviewed the critical and high ones, 2,000 high-impact ones, and a lot of secret leaks and personal data leaks too. Let me go a bit more in depth. For the vulnerabilities, on the high ones, we had SSRF, zero-click account takeover, about 250 dependencies vulnerable with CVEs. We reconfirmed the CVE that I mentioned earlier, so they did not fix it. And we also confirmed a lot of broken access. Some file declosure, this was pretty weird because some people actually, they generate, this was really interesting to find. Some people, they will generate it, but not deploy it on Lovable, probably because you have to pay. So they will just whack the code in their home laptop and serve it on the internet so you can access the Git repository or stuff like that. It's just leaking stuff on the computer. And a lot of misconfigured permission or broken access control, which came from the RLS that I mentioned before. So our guess was pretty good to say that this was probably very vulnerable. In the secrets, we identified GitHub tokens, a lot of OpenAI API keys too, because they love to build LLM wrappers. But who needs a backend when you can hard-code the key in the front end? It's so much easier. So yeah, they just throw the API key in the front end, make calls directly to ChatGPT, and ta-da, you have a wrapper. We also found some admin payments API tokens that were actually active, one of which was a Stripe token, and a lot of passwords, JWT, blah, blah, blah. For the PII, we found medical records, IBANs, phone numbers, emails, the whole package. Let's deep dive in a few of those vulnerabilities. The first of which, it was an application that leaked all of the GitHub application tokens. So you can basically steal the GitHub apps, which can be very problematic. And this is related to the CVE that I was mentioning. It uses the same vector, which is basically just you bypass the row-level security by just passing a select that is select everything in the table, and ta-da. This one is a very nasty one. It was a medical platform, connecting doctors to patients. And we a certain chain of requests, you were able to leak all of the doctor's info, containing the full name, the birth date, the phone number, the license number, which is like a medical license number, the bank IBAN, the email, the password, which is clear, of course. And you can see that this guy is a clinic psychologist. This one was really, really scary. And last one is zero-click account takeover of basically every active session on the website. So you are able just to dump all the sessions of the users, and you can just take the tokens, impersonate someone, and do whatever you want, including the admin accounts, of course. Yeah, so to conclude, a lot can go wrong when you vibe code your front end, but a lot more can go wrong when you vibe code your backend and your database. So please don't do it. Some mitigation strategies. This is very enterprise focused, but first, try to have a continuous mapping of your attack surface, whether it's APIs, but not only like your web applications or whatever. Either do it internally, that's the best way, just like map everything right from your code. Or if you cannot do that because you are a large enterprise, you have a lot of teams, just use some tool. Escape ASM does that, but a lot of applications does that too. Do some continuous pen testing on it. Manual pen testing is amazing. I always say that like no tool, Escape or any other tool will ever replace that, but it's a very nice addition to just be able to start a scan right when you deploy your code, like from your CI/CD, and to just get all the low-hanging fruits and make sure not to deploy something too vulnerable on the internet. So do that. Third, try to apply some security by design. This is everywhere too. It's a bit of a buzzword too, but the shift-left security, to try to just communicate with the developers, to inform them about security, to think about security right into the prototyping phase or development phases. And last, please, if you do use AI to generate code, I do too, it's great. It saves a ton of time, but review the code. And do not vibe code like your access control layer or your database schema, I beg you. So thank you. I hope you liked the talk. You can give feedback with this QR code, and if you have any question, I'll be happy to answer.
Thank you so much. We only have time for one quick question.
Thanks for the session. You said that you gathered some targets from the internet. I'm just wondering about the legality and if you faced any issues because you did it like that.
As said the previous speaker, I should have bet on this question. It's always the first question, of course. So basically, TLDR, yes, it's legal as long as you disclose the stuff and you are not using what you find in malicious ways. It also depends on the country where you perform that. But yes, this was done in a legal environment. And no, we did not face any issue. The platform themselves, they probably didn't notice because it's just not that much traffic. We tried to make it not so aggressive, as I mentioned. We try to send as few requests as possible, both for not destroying stuff and being fast and scalable. This is the full thing of scaling stuff to scan. And we disclose vulnerabilities, but most of those companies, they never reply because, if you just vibe code your application, you won't ever just have an email to. Some of them replied, but yeah, most of them do not and don't care. And a lot of applications were actually already pwned or pwned after that, and tokens were revoked or, yeah. Thank you.
Thank you.
All right, let's give Nohé a round of applause then.